everyone. Today we're going to talk about fractions with the denominators of 10 and 100. We're going to first talk about how to find equivalent fractions for these denominators, and then we're going to use that to help us add fractions with denominators of 10 and 100. So let's go ahead and get started. Now we've already done equivalent fractions, so this really should kind of be a review. If I have a denominator of 10, how could I make it equivalent with a fraction that has a denominator of 100. So I actually have some models here to help us out to visualize. So 7/10 is equal to how many hundredths? Well, if I have 7/10, so I'm going to shade in 1, 2, 3, 4, 5, 6, and 7. So I'm just going to kind of shade that amount in over here. Now on this side, when we have our hundredths, we have taken a tenth and we've just broken it down into 10 smaller pieces. So, these kind of resemble like the flats, when you guys learned how to count in like your lower grades, we had the 10 rods and then we had a hundreds flat. So think about that now. Instead of being 100 ones, it's a hundredths of one whole. So I'm going to shade in the same amount over here. So now instead of just shading in 1/10, I'm actually shading in 10 hundredths. So here I can kind of skip count by 10. So 10, 20, 30, 40, 50, 60, and 70. So if you count by tens instead of just singles like over here, you come up with 70. So 7/10 is equal to 70 100ths. And what's another way we can do this? Well, before, remember, we learned that we could generate equivalent fractions by multiplying. What's the rule? The number on the top and the bottom has to be the same. So how would I get 100 if I'm starting off with 10? I can multiply 10 times 10, and that would give me 100. Since the number has to be the same, then I would also multiply by 10 up here. 7 times 10 gives me 70. Let's try one more. So if I had 30 hundredths, so this time I'm starting off with the hundredths. Okay, so remember, each time I go down, here's 10. So 10, 20, 30. Okay, it's so hard to draw in a straight line on here. 30 hundredths. Okay, and now if I shade in the same amount, so if I just went down 1, 2, how many tenths did I shade in? Okay, you should notice that I shaded in, or I'm trying to shade in, only 3. Okay, so 3/10 would be the answer here. And again, we can use, some strategies we learned previously. Instead of multiplying though, because I'm trying to consolidate, I'm trying to make as few pieces as possible. So remember, when we talk about simplest form, we would divide. So if I have 100, what would I divide by to get 10? I would divide by 10. And if I had 30, I would divide by 10 because this number has to be the same, and I would get 3. So 30 100ths is equal to 3/10. So let's go ahead and try a couple of these. I have models here if you would like to use them, or if you want to use the other strategy, go ahead and pause the video and figure out what 4/10 would be in hundredths. Okay, so if you use the models over here, you would have shaded in 4/10, okay, or 4 of these bars. And then if you were to do the exact same over here, you would shade in 10, 20, 30, 40, okay, 40 100ths. Or if you multiply, okay, multiplying 10 times 10 would give you 100, and then multiplying 4 also times 10 would also give us 40. So 4/10 is equal to 40 100ths. Okay, next one, the opposite. So we have 80/100ths. Go ahead and pause the video and figure out how many tenths that would be. Okay, so here we're having to simplify, okay, or we're reducing the number of pieces. So we can't multiply here, we have to divide. Or if you use the models, which I can erase really quick. All right, and I have blue. If you were to use the models, okay, we had 80/100, so 10, 20, 30, 40, 50, 60, 70, 80. Okay, this whole space, this whole space in here would be 80/100ths. And if I were to fill in that same amount of space over here, okay, you notice I have kind of 2 columns remaining over here. So over here, and here if I'm just counting the tenths, okay, 1, 2, 3, 4, 5, 6, 7, 8. So 8 tenths would be your answer there. All right, or again, we can divide, okay? So 80 divided by 10 and 100 divided by 10 would also give us the 8 tenths. All right, one more. On your own, go ahead, pause, and try to solve 5 tenths. What would that equal with 100 as a denominator? And for this one, you should have gotten 50/100ths. Okay, again, either multiplying both of them by 10 or drawing, and using a model. Also, if you recognize that 5 tenths is equal to 1/2, you could think, well, what is 1/2 of 100? Okay, it's 50. So again, kind of reviewing how to do equivalent fractions, just really focusing on the denominators of 10 and 100. So now that we can do this, we actually can add and subtract fractions that have these denominators, because we haven't done a lot yet this year, but next year in 5th grade, you will be adding and subtracting fractions with uncommon denominators. And in order to do that, you actually have to create a common denominator, or in other words, the number on the bottom has to be the same before you can add and subtract. So what does that mean exactly? Well, if I have 60/100ths minus 2 tenths, I can't just take away, I can't just do 60 minus 2 and say it's 58, and then I can't just do 100 minus 10 and say it's 90. Okay, remember, the denominators represent the number of pieces we have. And when we are subtracting, we always have to have the same number of pieces before we can actually add or subtract the fractions. So your choice is always going to be to figure out which one you need to change. And most often, it's going to be a lot easier or necessary to change your fraction that has the 10 as the denominator, because what we can do here is we can just multiply our numerator and denominator by 10, and then we can substitute with our new fraction. Or better yet, instead of crossing that out, I'm just going to write the zeros with it. Because remember, a good trick that, we learned previously is that when we're multiplying numbers by 10, all we have to do is what? Add a 0 to the end. So if I do that, 2 times 10, okay, gives me 20, and 10 times 10 gives me 100. So now I have 100 as my denominator here. My denominators match, so now I can subtract. And so now the problem looks a little bit different from the way it did before. Now, it still stands that my denominator stays the same, so I can go ahead and carry that over, and I already have half my answer. And now I just need to do 60 minus 20, which if you can do that in your head, or if you need to do some scratch work on the side, that's fine. But you'll get 40. Okay, so 40/100ths, okay, is our answer. You can simplify this. You could divide everything by 10 again, and you would get 4 tenths, or you can leave it as this, because remember, those would be equivalent to each other. And now sometimes our answer won't, always be nice and neat and always have, a 0 at the end. So here I have 25 hundredths and 3/10. Okay, so again, I'm going to convert my tenths into hundredths. So I'm going to multiply these by 10. So 3 times 10 is 30, and 10 times 10 is 100. So now my denominators match. So I can add them now. And here, okay, I have 25. It's just like what we've done before, right? When we're adding and subtracting, we are really just working with the numerators. It's just the extra step of making the denominators the same. That's all we're doing. Another thing is just making sure that you do change your numerator as well. Don't leave it, because then you'll have a very different number. So make sure that you are multiplying both your numerator and denominator by 10. So 25 plus 30, okay, is 55. So 25 hundredths plus 3/10 or 30 hundredths is 55 hundredths. Okay, we're going to do a couple of quick extra practice problems. So for starters, go ahead, pause the video and solve 5/10 plus 4 hundredths. Okay, so I'm going to, again, just, real quick, multiply my tenths to get that same denominator of 100. I need that before I can do any work here. So 10 times 10 is 100. 5 times 10 is 50. And you're probably thinking, well, this is only 4. Do I need to change it? No, because I didn't change, my denominator. So my numerator can be left alone too. So here I really am just doing 50 plus 4, which will give me 54. So I have 50 hundredths plus 4 hundredths. And later on this week, we're going to talk about, the relationship between these fractions and decimals, and why it's so important to make sure we are pronouncing it correctly, tenths and hundredths, that THS at the end. And one more, I believe, yep. All right, one more to finish up. 8/10 minus 17 hundredths. Go ahead, pause, and see what you get for that one. Okay, like we said before, we can't really change our hundredths over here. 17 is actually a prime number, so. And then 8/10, I'm going to multiply, okay, by 10. So 8 times 10 is 80. 10 times 10 is 100. So now I have 80 hundredths minus 17 hundredths. Okay, so I've got my hundredths and my denominator here. And I'm going to do some scratch work over here. 80 minus 17. Okay, I'm going to have to regroup. 10 minus 7 is 3, and 6 minus 1 is 5. So, oh, I totally did that wrong. I need to put a 7 here, and then this would be 6. I hope y'all caught me and were yelling at your computer screens. So 80 minus 17 is 63. So I have 63 100ths. Okay, and as always, like we said before, if you ever do have your answers, like, just going back here, like 40 100ths, just understanding that sometimes, like on a test or a quiz, they may reduce the answer into tenths again. So just really understanding that relationship between tenths and hundredths, and how you can convert between the two, finding those equivalent fractions. So for your lesson today on IXL, lesson P.9 is going to just review the equivalent fractions for tens and hundredths in the denominator. And then in the R section, there is a new lesson. It doesn't have a number, but it's gonna review the adding of the fractions. So P.9 and the new lesson in R. And that is it. Have a great day. Bye.